Hello everyone, Gaza Mutkarsh, and I welcome you all to this session on data automation with Python scripts. So guys, let's have a look at the agenda for this session. The agenda for this session includes understanding loop tasks using pandas and NumPy, and for its implementation we'll be considering a case study or the use case, and for that use case we'll be creating multiple functions. The first function, let's say, would be used for synthetic data generation. The next follow-on function will be used to process the individual files that would inform data cleaning and transformation, and the next function would be to loop over all the files. And then towards the end we'll be creating a main function to call all these functions in a sequence or in a pipeline. So guys, so far till the previous session we have discussed automating file input, and we have also discussed batch operations using NumPy and pandas. So guys, let's switch to the Jupyter screen. So guys, currently we are in the Jupyter. So first of all, we'll be understanding what do we mean by looped tasks. So guys, loop tasks it involves applying the same processing logic repeatedly across, let's say, multiple groups in the data set, maybe over a batch of files, multiple columns, multiple time windows, multiple features or files, and even, let's say, multiple files and then multiple folders. All right, so this is what we refer to as looped tasks. All right, so when wrapped in a structured function or loop, these workflows become repeatable and scalable for new or unseen data. So for instance, I want to maybe rename n number of files present in the same folder. So this is an example of looped task. Likewise, we want to process different batch operations, all right, one after the another over a sequence. So again, this is an example of looped tasks. So for its implementation using NumPy and pandas, we'll be considering a case study. So what is the use case that we are considering? We are considering student exam analytics across multiple subjects. All right, so maybe we have, let's say, multiple subjects onto which the students are being examined. So we'll be using the looped task concept using the NumPy and pandas for its implementation. So over here, our objective is to analyze a student data set containing scores across multiple subjects. Now, what are the requirements or objectives? The requirements or the objectives over here include loop over each subject, then normalize the scores per subject. Then we have to flag students who are below average. We have to aggregate stats per subject. Let's say stats for what? Stats for scores, all right, for each subject. And then we have to save per subject report and one final summary. So these are our requirements or the objectives. So let's see them how to implement this in pandas and NumPy. So over here I'm importing pandas as PD. Next I'm importing NumPy as NP. I'm also importing OS, and next I'm importing from datetime, import datetime and time delta. So pandas we are using for data pre-processing, NumPy for mathematical or numerical calculations, OS, let's say, for file handling, and datetime just in case we need to handle date and time based scenario. Time delta we are using to compute, let's say, addition subtraction operations on the date time. So the first step required over here is to, let's say, the first prerequisite is to set up the folders. So over here I'm setting up an output folder. The output folder is subject reports. All right, over here the output folder that I'm passing is subject reports. And next over here I've mentioned os.make directories, output directory. If it does not exist, create this folder. All right, so if this folder does not exist, then create this folder. What is the folder that I'm creating? The folder is subject reports. The folder that I'm using over here is subject reports. All right, this is the folder that I'm creating. So let's create this. Currently, if you observe, we don't have a folder called subject reports, right? So let's create this. All right, so guys, this we have implemented. Next, we have to generate sample student exam data. Let's understand the objective. So basically over here we have to generate synthetic student exam data. Means we can write either sample or synthetic, both implying the same thing. So let's see what is the objective. The objective over here is to create a function that takes number of students and arguments and add the following functionalities. So what are the functionalities? We have to generate, let's say, synthetic math physics, chemistry and computer scores for each of the student ID for a specified date range. I'm assuming date is not required over here. Yeah, date is absolutely not required. So the objective includes generating synthetic math, physics, chemistry and computer scores for each of the student ID. Then we have to inject some errors because that is where data cleaning and transformation comes into picture. Next, we have to save the file to a specified path. So for instance, if the table name is df as in the data frame, so how should the table structure look like? It should appear somewhat like this. We should have student ID, then math score, physics score, chemistry score, and the computer scores. All right, the function takes the argument as number of students. So over here, I'm calling the function as def, let's say def I'm using to create the function, then generate student data. This is the function name, and what are the arguments? It takes number of students. The default number of students that I've passed is 100, means this function will generate records for 100 students. np.randomSeed, this is for, let's say, setting some set default randomness. This is used to set default randomness. Now over here I'm creating a dictionary. The dictionary takes the first parameter as the student ID. The first key is the student ID. How am I creating student ID? Over here I've used a list. So this is S, then string of I dot z fill 3 for I in range 1 to number of students 1. All right, 1 to number of students plus 1. So this is a string function. All right, and let's say it reseeds the singleton random state instance. This is the purpose. So we have let's say set the random seed over here, and this is used for reseeding. So this would be the student ID. Then in the math score over here, I'm passing np.random. I want to have normally distributed data between, let's say the mean over here is, what is the mean? The mean that I'm setting is 70, and the scale or the standard deviation that I'm setting over here is 10. So this is for the math score. And what is the number of students? The number of students that have passed is 100. Now for physics, again the mean is 65 and the standard deviation that I've set over here is 12. For chemistry, the mean is 75 and the standard deviation that I've set over here is 8. Next, for computer, the mean is going to be 68 and the standard deviation that we have over here is 9. So guys, this is the data that we have. I'm creating math scores using np.random.normal. All right, I'm creating normally distributed data with a mean of 70 and standard deviation 10 for 100 students. Likewise for physics, again we are creating normally distributed data with a mean of 65 and standard deviation of 10 for 100 students, standard deviation of 12. For chemistry, normally distributed data is being created with a mean of 75 with a standard deviation of 8 and the number of students being 100. And same goes for computer, where we are creating normally distributed data with a mean of 68 and standard deviation of 9 and the number of students being 100. All right, so guys, this is the dictionary. Now over here I just need to pass this dictionary as let's say argument for the data frame. So this would end up creating a data frame. Now I need to inject the errors, right? So this is this was the first step. This was let's say data generation. This was the synthetic data generation. All right, and the second step over here is create data frame. The second step that I'm using over here is to create the data frame. The third step over here is to inject the errors. So what are the errors that I'm creating? What are the errors that I'm trying to include? Let's understand this. So for few particular indexes, or maybe for just for one particular index, I've entered the math marks as 999, and maybe for okay, this is math, then maybe for chemistry I'm setting the marks as negative marks, right? And likewise I'm applying the same logic maybe to at index maybe 54 for computer. The marks entered is, let's say, again some let's say some negative values, and likewise I'll apply the same logic for physics. And over here the marks entered is maybe something like this. So these are the errors that we have added. Now maybe if need be, we can also add some let's say null values as well. So this is where I'm injecting the errors. So we have generated synthetic maths, physics, chemistry, computer scores. We have injected some errors, and let's say if need be, we can save the file to a specified path. Or over here, what am I doing? I'm simply return the data frame. All right, the function should return this data frame, or function should return this student data. Return the student data. All right, so this is what we are returning, and we have returned it over here. So let's run this. Let's execute this. So over here we are proceeding with synthetic data generation. We have created the data frame, and then we are injecting the errors. So this part is done. Now, because we haven't called the function yet, so it won't get executed. We have just created the function. So this was the first step. Now the second step is to process the individual files. All right, how would I process the individual files? What is the objective over here? We have to create a function that takes student file and subject as argument and add the following functionalities. So we have to read the file, we have to clean the invalid score, we have to, let's say, normalize the scores, and then we have to flag below average scores, we have to return per subject summary and save subject wise report to our output directory. What happens to be our output directory? This was our output directory, right? This is our output directory. So if you observe over here, see, subject reports has been created. Subject reports has been created over here. Now currently this is an empty directory because we have not added any files to this directory yet. So let's proceed with processing the individual files, and these are the objectives. So let's implement them one by one. So the function that I'm creating is process subject score, and it takes two parameters. The two parameters are df and subject. Df is the student data, subject is the subject onto which I need to work. All right, so first step is to, let's say, okay, read the file is already done. I think reading the file is not required, or maybe I can just pass subject. So maybe I can get the way I've implemented, I don't need this. So the first step is to clean invalid scores. So this is, let's say, data cleaning. How do I clean the invalid score for any given subject, right? Over here I'm setting the rule, if the subject value is less than 0 and if the subject value is greater than 100, then I have to fill it with nan values. Then I'm filling it up with nan values or empty values. Otherwise we'll keep it as subject. So simple straightforward rule, if the subject value is less than 0 and if the subject value is greater than 100, means the score is invalid. So I'm filling it up with null values. Otherwise it will remain as it is. Otherwise we need the data, it is meaningful data. The next step is to normalize the scores. So how do we normalize the scores? We have discussed normalization, means this is essentially the scaling part. So first of all I need to find the mean of the subject. Then I need to find the standard deviation of the subject. Maybe I can mention DDOF is equal to 0. So this is the subject mean and this is the subject standard deviation, right? This is the subject standard deviation. Next over here I'm writing DF subject Z score. Z score is the normalized score, or maybe I can mention the norm score. Norm score, this is DF subject minus mean upon the standard deviation. So in the data frame I'm adding another column, and this is kind of the data transformation step. This was the data transformation. All right, so step 2, and let's say normalize the scores, flag below average scores, all these are data transformation steps. So we have computed mean, we have computed the standard deviation, we have also computed the normalized scores. Then how to flag the below average score? This is the third step required to flag the below average scores, right? Over here in the subject I'm writing flagged. In the subject, let's say I'm creating a new column, a new feature, which would be referred to as subject underscore flagged. And how would I let's say set it up as flagged? How is it flagged? If the student have scored, let's say, below average, so mean we have computed over here, right? So if the subject is below mean, so essentially it is going to return true and false. Essentially it is going to return true and false. All right, so if this is not done, then maybe I can write np.where if df subject less than mean, then true, otherwise false. I can also write it like this. All right, so if the score is less than mean, then yes, the subject, that particular student is flagged as true, otherwise flagged as false. So then I need to compute per subject summary. So for each subject, the summary would include the minimum score, the maximum score, the mean score, the student ID, and let's say count of scores, maybe. So over here, the summary, I've created it as a dictionary. So the subject is the subject which I passed over here. Then I need to find the mean score. So mean score is already computed over here. So I'm rounding it up to 2 decimal places. Then I'm computing the standard deviation, that is rounding the standard deviation up to 2 decimal places. So again, the key is stddev, and this is the value. Below average count. So over here, I'm simply counting the sum of, let's say, all the records where for a particular subject the student has scored less than the average. All right, and this would simply count the number of records. And then valid scores is in, let's say, I'm simply counting the subject count, how many times that a particular subject score has been, let's say, displayed. So these are the valid scores. So this is the summary. Next, I need to, let's say, save subject wise report, right? Save subject wise report to the output directory. So this is the fifth step. And over here, how are we saving the scores? Let's understand this. To save the subject wise report, over here I'm creating a data frame called subject df. This data frame subject df takes student id. Then the second parameter that I'm passing over here is the subject. Then I'm passing subject is z score. So I've renamed it, right? So let's call this norm score. And then let's call this norm score. I'll keep n into lowercase. Then over here I've mentioned subject underscore flagged, which is these. So these are the 3 columns, right? I'm considering the subject. Let's understand the columns that we are considering in the subject data frame. The student id, the subject, subject normalized score, and subject flagged. All right, now I'm saving this data to CSV, and over here I've mentioned output path. This is the output directory. Then I need to pass the file name structure. So the file name structure is subject underscore report.csv. So this would be created for each and every subject. This is going to get created for each and every subject, and the index is going to be false because I don't want to have any extra indexes in my data frame. Next, I'm simply returning this summary. All right, I could have returned the subject df as well, but currently I'm returning the summary. If need be, will be, let's say, we can proceed with returning the subject df as well. So guys, this is the function to process subject scores. We have seen this function, how it works. So it has 1, 2, 3, 4, 5 steps, and let's say the 6th step is to return the summary. This is where we are returning the summary. Now this function is only valid for one particular subject. How many subjects do we have to begin with? We have not mentioned the number of subjects, right? So see, over here I'm passing like this. We do have 4 subjects: maths, physics, chemistry, and computer. So for each of these subjects I need to generate the report, but this function currently only handles a single subject. This is where, let's say, looped tasks comes into picture. So the third function, we are headed towards the third function. Over here the objective is to batch subject loop. Now over here we need to create a function that takes file path, or let's say that takes let's say student data as argument, and adds the following functionality. What are the functionalities? We have to loop over all the subjects, apply process subject scores. This is the function, right? Process subject scores. We have to apply on each of the subject. We have to apply this function on each of the subject, and then we can save summary in the list. So let's see how we are implementing it. Over here I've written def loop over subjects. Loop over subjects is the function name that takes student data as the argument. What are the subjects that we have? For the subjects we have math, physics, chemistry, and even computer. These are the 4 subjects. And then I've created an empty list, I'm calling it summaries. So for subject and subject columns. So for each of these columns, for each of the subject value, the subject data is stored in this variable. Then I'm printing processing subject. So summary would be process subject scores. All right, over here I'm passing process subject scores, and then instead of this df I'm passing its copy. Why copy? So that any changes made to the original data frame do not get reflected over here. And then I'm passing the subject. So whatever is the result obtained will be stored in this summary. Now this summary over here is this dictionary, right? So what is this returning? Now summary returned over here, right? Summary returned over here is the dictionary. So this function returns a dictionary. Function returns summary, all right, which is a dictionary. Now summaries dot append, what am I appending it with? This summary that we have over here. So what is the data type, what is the nature of this summaries over here? So summaries would become a list of dictionary. All right, it would become a list of dictionary. And then what are we returning? We are returning pd.data frame summaries. So I'm converting this let's say list of dictionary to data frame. So now this would be a data frame. All right, so this is where I've enlisted all the subjects. I've enlisted all the subjects over here. This is where I'm looping over the task. This is where looped tasks comes into picture. And then what am I returning? Return the list of dictionary as a data frame. All right, so now all these functions have been implemented, as in have been executed. Now to call all these functions at once, this is where we need to have a main function where I can apply this function, let's say onto the data set generated over here. All right, onto the data set generated over here, I want to apply this function. So the fourth step over here, I missed this. The fourth step is to return the data frame, return the student data as a data frame. All right, next. So moving on from the third step, let's head towards the fourth step. The fourth step over here is to call the above created functions inside the main function. So over here, the objective is to create a main function, then call the generate student data function, then generate student data, right? Next, we can call the loop over subjects, and we have to save the summary to a CSV file. This is the last step. So over here, let's say first of all, the first step is generating student data for different subjects. This is the first step. Then the second step is generating summary data frame, all right, for each subject. Now once this is generated, then this summary df, I'm saving it to save the summary data frame, save the summary data frame to the output directory, all right. And the file name that I would set over here is subject summary.csv, and I'm setting the index as false. Over here I'm setting up the index as false. Next, what are we doing over here? We are simply returning this data frame. Return the summary df, all right, summary data frame. So once this is done, maybe I can call the function. So because it is returning the summary data frame, this function over here is returning the summary data frame. So what I can do, I can call this summary df is equal to main. Let's run this. So over here it says processing subject maths, physics, chemistry and computer. So all the subjects have been analyzed, and if we observe over here, so the student report, subject reports, right, we do have the data. So for each of these subjects we do have some report. So if you observe, this is the chemistry report, all right, and we do have 100 scores of 100 students, all right. Then we do have computer report, we do have scores for 100 students, and we do have let's say normalized scores as well. So let's see this report, summary df.head. So guys, this is the, let's say, summary for each and every subject, and these are the mean scores, standard deviation, below average count and valid scores. So let me run this. Yes, this is the summarized data frame. So we only have 4 records for each subject. This is the mean score for all the students, this is the standard deviation, this is the count of below average students in each subject, and these are the valid scores. These are the valid scores as far as each subject is concerned. So this is the summarized report. Now if we want to read these files, if I want to read these files. So maybe over here I can read these files as well. All right. So os.path.join, this is the file, right? Where are we creating the file? The file is created over here, os.path.join, and then subject report.csv. Let's read one of the files, one of the student data. Let's read one of the student data. So we are already done with the loop task. I'm just trying to show you one of the student data generated. So this is maybe for the subject, I'm writing maybe maths. It is math. All right. So over here I'll be writing math. So do we have math report over here? Yes, math report.csv. And where is it present? In the output directory. So this is the file path, right? This is the path. Now, if this is the path, so I just need to write maybe math report as, let's say, pd.read csv, and then I can pass f path. This is going to be math report. So guys, as we can see, this is the id, and over here we can see we can observe that we do have 100 records. This is the math report that we have. Likewise, we can read the scores for other subjects as well. So guys, that brings us to the end of this session. So let's switch back to the PPT. So guys, in this session, we have understood how to work with loop task using NumPy and Pandas. So headed forward in the next session, we'll be discussing into the visualization essentially using Matplotlib and Seaborn. Thank you.